good day, all of you. So, today we'll not have a physical lesson because of some circumstances. You guys should know that we are busy preparing for the next month of October, which starts on the 27th. Tomorrow a new month is starting the tuition, because you know that you started at around the 17, 18 day. Yeah, but I've heard some of you saying we are doing dynamics part 1. So in dynamics we study how objects move. How do they move? What happens to an object when it's moving? What really makes the object to move? So now we see that for an object to move, we need to have force, or the principle of force need to be involved for the object to move. Now, what is force? Force is the push or the pull. So when you are pushing something, that's force. So you can just grab something that we have, grab your pen, put it down the table, try to push it. I'm pushing my pen, try to pull it. I'm pulling my pen, or the curtain, try to pull that curtain in front of you there. If you have someone who have hair, artificial hair, pull that hair. Yeah, so that's so what is the unit of force? The unit of force are Newton. Force is measured in Newton. That's true? Yes, that's true. You know that 1 Newton in dimensions we said is 1 kg meter per second squared. Wow, I still remember these things. Yeah, I was just adjusting my view so that you can see. Now, what happens when you push an object? When you push an object, the object moves and the velocity of the object changes. Now, we have the Newton's laws of motion. We have the first law of motion. It states that in the absence of external force, an object remains at rest or continue to move with constant speed in a straight line or constant velocity. What you are saying is that when the object is stationary, like you put your pen down, that pen is stationary. Newton says that object will not move unless there is a force acting on that object, or if an object is moving at a constant velocity. Let us assume that an object is moving at 20 meters per second. That object is going to maintain that speed unless or until there is a force which is going to act. It's going to act on that velocity. That's the first law of motion. Now, this is a law of inertia. The second law of motion is that the acceleration of an object is directly proportional to the net force acting on the object, and it is in the same direction of a force. Let's assume that you are pushing your pen. Your pen is resting there. We are saying that the more force you apply, the more acceleration. So the increase in force is the increase of acceleration. So that is a vector equation. When you say something is a vector equation, you mean that there are vectors which are involved there. I hope you understand. There are vectors which are involved there. So a force is a vector and acceleration is a vector. So F equals to ma. So that E sign is called summation of Fx. So you are saying that for you to find the total force acting, should you make sure that you divide the force into 3 parts. There should be force in the x-axis and the y-axis. Now, let us move on to the example below there. You see that there is a box with some black dots. There's F1. So F1 and F2, they are on the x-axis. Mind you, I told you that vectors, they appear into 2. They are either acting in the horizontal or vertical. So just like we are doing in vectors, the vectors in which force is a vector, mind you. So the vectors which are on the horizontal are called the x-axis. They are the I vectors. So you should know that when you go to your left, the Cartesian plane is positive x-axis. When you go, when you go to your right, directions are a problem. When you go to your right, the x's are the x-axis are positive. When you go to your left, the x's are negative. When you go up, the y is what? The y is it positive? Yeah, it's positive. When you go down, the y is negative. Now, I want you to get this now. The axis in the horizontal, you are going to add them. Mind you, those axes with the arrows facing to the left, to the right, are positive. Those axes with arrows facing to the left are negative. So here you are going to, so the F3 force there is a vector force at an angle. Mind you, I told you that when a vector is acting at some certain angle, which is not 90 degrees, because 90 degrees is x-axis and y-axis. When the vector is acting which at some particular angle, which is not 90 degrees, that vector, you are going to resolve it into x-axis and y-axis. That's why you have f3x. So the f3x there in that diagram in example 1, the f3x there is the vector of f3 in the x-axis. So the f3y there is the vector of f3 in the y-axis. Go back to vectors and know how to resolve a vectors. Now you are going to the total forces of F, the summation of F, that's EF, is going to be the forces acting in the x-axis and forces acting in the y-axis. You just leave your answer like that. So let me pause here so that I can be able to upload this video in WhatsApp, and I'll continue with the momentum.